Hey, deep diver. Looks like you're really looking to up your game in Azure DevOps with all this YAML pipeline stuff.
Mm.
Yeah, you sent us a ton of documentation. Must be pretty serious about mastering CI/CD, huh?
Yeah.
But don't worry, we've gone through it all. You don't have to.
That's right. We've got you covered. We'll break it all down for you, highlight the tricky bits, give you some real-world examples, and share some of the tips and tricks we've picked up along the way.
Okay, cool. So let's get right to it. First thing that jumped out at us is that you're really interested in, really customizing those pipelines. And it turns out it all starts with a YAML file, right? Specifically that Azure-pipelines.eml file.
Right.
Kind of like the blueprint, the DNA of your pipeline, I guess.
Yeah.
Usually hanging out at the root of your repository.
Yeah, and the interesting thing here is that this single file, it really defines the whole structure and behavior of your pipeline. Everything, from the big stages all the way down to the smallest tasks and steps, all live in that YAML file.
Okay, so stages, jobs, tasks, steps. I'm getting flashbacks to like high school sentence diagramming here. Maybe we could break down that whole hierarchy a little bit.
How about we think about it like a construction project?
Okay.
So the stages are like the main phases, build, test, and deploy. Jobs are the specific work crews within each of those phases, and the tasks are like the actions that those crews do. And then finally, the steps are those super granular commands that make up each task.
Gotcha. So like if I have a pipeline that has several steps, build my code, run the tests, then deploy it, that's where stages come in.
Exactly. Multi-stage pipelines, those are perfect for longer, more complex processes, or when you need approvals along the way. Like you might want someone to sign off before you deploy anything to production, right?
Makes sense. And then to simplify things, we have these pre-built tasks, right? Like having prefab components that you just slot into your pipeline.
Precisely. There's a whole library of built-in tasks, ready to use, covering a huge range of common actions. Compiling code, running tests, deploying to different platforms, it's all there. And if you need something a little more niche, you can create your own custom tasks or even group tasks together into these reusable templates. Pretty flexible.
Nice. Speaking of automation, let's talk about triggers. Those are what kick off your pipeline without you having to manually hit a button each time, right?
You got it. You can set your pipeline to trigger on all sorts of events, like whenever code is pushed to a specific branch, a pull request is created, or even on a set schedule. Like you could have it run a build every night while everyone's sleeping. Automation at its finest.
Love it. But what happens when those triggers aren't working like they should? We've all been there. You're scratching your head, wondering why your pipeline isn't running.
Yeah, troubleshooting triggers can definitely be tricky. A lot of times it comes down to just double checking your configurations, making sure everything matches up in the YAML file and the Azure DevOps UI. Sometimes those settings clash and things get, a little unpredictable. And you also got to keep in mind things like excluded branches or file paths. Those can mess with triggers too.
Good point. All right, next up, variables. They're like the wild cards in a card game, right? You can swap them in for different values throughout your pipeline.
That's a great analogy. Yeah, variables make your pipeline super adaptable. You can have user-defined variables for values that are specific to your pipeline, or variable groups if you want to share variables across several pipelines. And then there are secret variables for things like passwords or API keys, the sensitive stuff.
Right. Speaking of sensitive information, those secret variables need some extra TLC, right? Especially when it comes to deployment jobs.
Absolutely. Security is, paramount. And deployment jobs are all about rolling out your application, so that extra layer of protection is critical. Always handle sensitive data with care.
For sure. So where exactly are we deploying to? That's where environments come in, right? They're like the different stages of a product launch, I guess.
Exactly. Environments, those represent your deployment targets, development, testing, staging, production, the whole 9 yards. They provide structure and features like deployment history, traceability, and even security controls. You can actually manage who has access to each environment right from Azure DevOps.
Okay, so we have our environments all set up, but what if we need an extra layer of control before things go live? Like a final check?
In those cases, approvals and checks are your best friends. They act as gatekeepers, making sure that your deployments meet certain criteria before they move forward. Like, think of it as a checklist to make sure everything is in order.
Like a final inspection before you open up a new store.
Yeah.
Right. Got to make sure everything's perfect.
Exactly. You might require manual approval before deploying to production, or you could set up some system health checks that need to pass before any updates are pushed. peace of mind.
Okay, so far we've covered the basic building blocks of a YAML pipeline. But before we move on, there's something I've always wondered. Can you actually delete a pipeline run, even if it's, supposed to be retained?
That's a great question. Normally, you can't delete a run that's marked for retention, but there is a way around it. You first have to stop retaining it, kind of like taking something out of a time capsule before you can DOS it.
Makes sense. All right, let's switch gears a bit and talk about something a little more visual. How about those status badges? Who doesn't love a good badge?
Status badges are a fantastic way to, well, show off the health of your pipeline. Keeps everyone informed at a glance. They're like those little indicator lights on your dashboard, letting you know everything's running smoothly.
And where do these badges go? Do I get to, stick them on my laptop?
Haha, not quite. They usually go places like your repository's readm file. Gives everyone a quick visual cue about your build status. You can even customize them to show the specific branch or scope you're interested in.
Okay, I'm convinced. Status badges are officially cool. Now, let's talk about some real-world scenarios where YAML pipelines really shine. We've been focusing on Azure repos, but what about working with GitHub repositories?
YAML pipelines work beautifully with GitHub. You can trigger builds based on events like pull requests or pushes to specific branches. It really streamlines your workflow.
I'm sensing a theme here. Triggers, triggers, triggers. They really are the heart of CI/CD, huh?
Yeah, you could say that. But one thing to remember when you're working with GitHub repos is permissions. You need to make sure everything is set up correctly on the GitHub side for Azure Pipelines to do its thing.
Permissions are always important. So if I'm using a GitHub repo that belongs to someone else, I need to be added as a collaborator.
Exactly. The repo owner also needs to grant Azure Pipelines access to their repositories. It's all about making sure everyone is authorized and everyone's on the same page.
Right. So let's say I'm working on a feature branch and I want to trigger a build, but I don't actually want to create any artifacts just yet. Can I do that?
Absolutely. You can use custom conditions in your YAML file to control what happens on specific branches. Like you could set it so that artifact generation only happens on your main branch. Saves time and resources on those feature branches.
That's super useful. Really highlights how much control YAML pipelines give you. Okay, we've talked about triggers and repos, but what about batching? How does that work? Especially when you have a ton of changes coming in at once.
Batching is a great way to optimize your builds and prevent redundant runs. You can configure your triggers to collect changes within a certain time frame and then trigger a single pipeline run.
So instead of kicking off a new run for every single commit, you're grouping them together.
Exactly. Imagine your team is all pushing their changes super fast. Batching prevents the pipeline from getting overwhelmed and keeps things running smoothly.
That's much more efficient, for sure. Now, back to security. How about protecting access to those repositories within your YAML pipelines? What happens when you're working with multiple repositories?
Protecting access to repos, that's all about making sure that your pipelines are only accessing the code they absolutely need to. With this setting turned on, your YAML pipelines need to explicitly reference any Azure repos Git repositories they want to use.
Like giving your pipeline a VIP pass to specific repositories.
You got it. And if you need to access repos in a different project, you'll need to update the permissions for those job access tokens. Keeps that security layer strong and prevents any unauthorized access.
Permissions are like the bouncers at the club, only letting the right people in. Now, what if I want to control how far back my pipeline looks into the commit history? Is there a way to tweak that?
Yeah, you can use the fetch depth setting to manage that. Controls how far back the pipeline goes when fetching commits from the repository. Really helpful for those massive repositories with a long history, when you only need to see the recent changes.
So if I'm working on a hotfix and only need the last few commits, I can just tell my pipeline to focus on those.
Exactly. It can save a lot of time and resources, especially when you're dealing with large files or binaries.
Efficiency is key. Speaking of saving resources, let's talk about a feature that speaks to my inner neat freak. Clean checkout.
Oh, the clean checkout option. That's like giving your agent a fresh start with every build. It completely wipes the source directory clean and starts from scratch. Especially helpful when you're using self-hosted agents where you might have some leftover files from previous builds hanging around.
It's like wiping the whiteboard before a brainstorming session. Fresh start, fresh ideas.
Precisely. Prevents any unexpected conflicts or issues from those leftover files and keeps your build environment nice and consistent.
Love it. Okay, so what about submodules? How do they fit into the whole YAML pipelines picture?
You handle those using the checkout step. You can choose to just grab the top level or go recursive and get all the nested submodules as well. Gives you the flexibility to work with different repository structures.
Like a branching storyline in your main narrative. Got to make sure you're following all the threads.
Exactly. And to avoid any surprises, the sync tags option makes sure your pipeline tags are all synced up with your repository. That's super important if you're using tags to manage releases or deployments.
Keeping things synchronized is so important, especially when development is moving fast. Okay, we talked about troubleshooting triggers earlier, but what about those dreaded build failures? Where do we even start?
Ugh, build failures. They happen to all of us. And yeah, they can be a real pain. The key is knowing where to look for clues. Luckily, the Azure DevOps UI has a ton of information about your pipeline runs. Logs, test results, any errors that popped up, it's all there.
Like you're some kind of detective gathering all the evidence.
Exactly. By digging into the logs and outputs, you can usually pinpoint the root cause and start working on a solution.
And sometimes those solutions involve some pretty creative workarounds. I remember one time I couldn't use the checkout submodules option for, I don't know, for some reason. I ended up using a custom script and a personal access token to fetch those submodules manually.
That's a great example of how understanding YAML pipelines can really help you problem solve in tricky situations. Sometimes you just have to, adapt and get things done.
Exactly. And sometimes that means understanding the finer points of different features, like gated check-ins.
Oh, gated check-ins.
Yeah, those sound interesting. What are they all about?
Gated check-ins are like having a quality control checkpoint before any code is merged into your main branch. They make sure every single change is validated before it becomes part of your code base.
So like a super strict screening process before anyone can get into your exclusive party.
You could say that. Gated check-ins usually involve triggering a build and running a bunch of tests just to make sure the changes don't break anything.
And if those tests fail, the changes are rejected, right?
Exactly. It's a great way to maintain that code quality and prevent regressions from sneaking into your main development branch.
Yeah, definitely peace of mind right there. Nice safety net to have. Now, we've been talking about single repositories a lot, but what about when you need to work with like multiple repositories in a single pipeline?
Oh, YAML pipelines are super versatile. They can handle multi-repository scenarios, no problem. You can specify multiple repositories as resources in your YAML file and define how they're checked out and used within your jobs.
It's like juggling multiple projects at once.
That's a great analogy. And just like with juggling, it takes some careful coordination and planning. But YAML pipelines give you all the tools you need to manage those dependencies and make sure your builds are nice and consistent.
That's pretty impressive. Okay, I'm curious now. How can you specify the exact agent you want to use for a specific job? Do you have that level of control?
Absolutely. You can define demands and capabilities for your agents, which basically act as filters to match jobs with the right agents. This is super useful when you have a bunch of self-hosted agents with different configurations.
So if I have a job that needs a specific operating system or a certain set of tools, I can make sure it runs on an agent that meets those requirements.
You got it. Make sure your builds are running in the right environment and have all the right resources, maximizes efficiency, and prevents any compatibility headaches.
That's super powerful.
Yeah.
Okay, what about when you have multiple jobs running within a single stage? How do you manage those dependencies and, make sure things are running in the right order?
Welcome back to our deep dive into YAML pipelines. We left off talking about how to manage dependencies between jobs within a single stage.
Right. Like a carefully choreographed dance. Each job has its moment, but they have to perform in the right order.
Exactly. You can use the depends on keyword in your YAML file to define those dependencies. That way you make sure jobs run sequentially. You can even set conditions for when a job should run based on, whether its dependencies succeeded or failed.
Okay, like setting up a chain reaction, one job triggers the next and so on.
Precisely. By orchestrating those jobs carefully, you can build some pretty complex workflows that handle everything building, testing, deploying, even monitoring. And speaking of testing, have you ever worked with matrix builds?
Matrix builds. Rings a bell, but maybe a quick refresher would be helpful.
Think of them as a way to run your tests in parallel across different combinations of variables. Like, say you want to test your app on different operating systems, different browsers, or maybe even using different versions of a library. Matrix builds let you define all those variations right in your YAML file, and Azure DevOps will automatically spin up separate jobs for each combination.
So instead of manually creating like a zillion jobs, I just define a matrix and let Azure DevOps do all the work.
That's the idea. Saves you a ton of time and effort, especially when you've got a lot of configurations to test. Plus, keeps your YAML file nice and clean, which is always a good thing.
Organized YAML files, developer's dream.
Yeah.
Okay, so you said matrix builds are great for testing. Can you give me an example of how you might define a matrix in a YAML file?
Sure. Imagine you want to test your web app on, let's say, Windows and MacOS using Chrome and Firefox. You could define a matrix like this. You'd have strategy, then matrix, and under that you'd define your operating system, so Windows with O's, Windows and macOS with O's, macOS. Then for the browsers, you'd have Chrome defined with browser, Chrome and Firefox with, browser, Firefox.
Got it.
That simple setup would create 4 separate jobs, one for each combination of OS and browser. And within each job, you can access the values of those matrix variables like O's and browser to customize how your tests run.
Pretty slick, like having a virtual testing lab where you can run everything simultaneously.
You got it. Matrix builds are super powerful for making sure your app works across all kinds of setups.
Okay, before we jump to the next topic, I want to circle back to something you mentioned earlier, custom tasks. You said we can make our own tasks if the built-in ones don't quite cut it. Can you walk me through that process?
Creating custom tasks is a great way to, extend the functionality of your YAML pipelines. You're basically creating a task definition file that describes, the task's inputs, outputs, and the script or executable that actually does the work.
So, like if I wanted to create a task to send a notification to Slack, I'd define inputs for things like the Slack webhook URL and the message, and then write a script that handles actually sending the notification.
Exactly. Once you've got that custom task all defined, you package it up as an extension and upload it to the Azure DevOps Marketplace. Then everyone can use it.
Sharing is caring. Okay, you also mentioned task groups. How are those different from custom tasks?
Task groups are more about reusability within your own pipelines. They let you bundle a series of tasks together into a single unit that you can reuse across different pipelines.
So if I have a set of tasks that I use a lot, say building my code, running unit tests, and publishing the results, I can create a task group for that and then just reuse it everywhere.
You got it. Saves time and ensures consistency. Plus, if you need to make changes to those tasks, you only have to update the task group, and all the pipelines that use it will automatically inherit those changes.
Nice. A great way to streamline things. Okay, we've talked custom tasks and task groups, but let's not forget the ultimate reusability tool, templates.
Templates. They're like blueprints for your pipelines. They let you define reusable chunks of YAML code that you can include in your main pipeline YAML files.
So if I have a common set of stages or jobs that I use in multiple pipelines, I can create a template for those and just reuse them instead of writing the same code over and over again.
Exactly. Templates are super powerful and flexible. They can help you build those really complex pipelines while keeping your YAML files clean and organized.
Music to my ears. Now, are there different kinds of templates you can create? Is it just stages and jobs, or can you create templates for other things too?
Pretty much anything you define in your YAML file can be templated. Stages, jobs, steps, variables, triggers, even resources, you can create templates for all of them. It's all about breaking down your pipeline into those reusable components.
Like having a set of building blocks and you can construct all sorts of different pipelines.
Exactly. Templates let you build a library of reusable building blocks that can seriously streamline your CI/CD processes.
Okay, so how do you actually use these templates in your pipelines? Is it as simple as copying and pasting YAML code?
There are 2 ways to use templates: including a template or extending a template. Including is kind of like inserting a pre-written chapter into your book, while extending is like adding your own notes or comments to an existing chapter.
So including brings in the entire template code, while extending lets you tweak or add to the existing template structure.
You got it. Whether you choose to include or extend really depends on how you want to reuse that template code and how much customization you need.
Makes sense. Now, templates often have parameters, so you can customize how they behave, right? How do those work?
Parameters are basically the settings or options you can configure for a template. You define them in the template's YAML file, giving them names, data types, and any default values.
So like if I have a template for deploying to Azure App Service, I could have parameters for things like the app service name, the resource group, and the deployment slot.
Exactly. And when you use that template in your pipeline, you can either provide values for those parameters or just stick with the defaults that are defined in the template.
Nice. A great way to make templates super reusable. Okay, before we move on, can you tell me a little more about template context? You mentioned it earlier as a way to pass data to templates.
Template context is a really powerful feature that lets you pass data from your main pipeline YAML file to the templates you're using. It's especially handy when you need to pass complex data structures like, lists of jobs or deployments.
So if I have a template for running tests and I want to pass a list of specific test suites to run, I can use template context to do that.
Exactly. It gives you a ton of flexibility in how you structure your pipelines and move data around.
Love it. It's amazing how much flexibility and customization these YAML pipelines offer.
Right. And now that we've got the basics of templates down, let's dive into one of the most important aspects of YAML pipelines: variables.
Variables.
Right.
They're like the spices that add flavor to our YAML recipes. But with so many different kinds of variables, it's easy to get lost. Can we break down the different flavors?
Think of variables as placeholders for values that you can use throughout your pipeline. You've got user-defined variables for custom settings, system variables for built-in information about the pipeline environment, and then you've got those secret variables for sensitive data passwords and things like that.
Okay, so user-defined variables are the ingredients we choose ourselves. System variables are like the pre-measured staples in the pantry, and secret variables are the special ingredients we keep locked away.
Haha, that's a great analogy. And just like with cooking, using the right variables in the right way is key to the success of your pipeline.
So let's start with the basics. What are some examples of how you might use user-defined variables in a YAML pipeline?
User-defined variables are great for anything you might need to change often or customize for different environments. Say you have a variable called build configuration that you want to set to debug or release, depending on the pipeline. You can define that variable in your YAML file and then reference it throughout your pipeline tasks.
So instead of hard-coding debug or release everywhere, I just use the variable and can change it in one spot if I need to.
Exactly. It makes your pipelines way more flexible and much easier to maintain.
Makes sense. What about those system variables? They sound like they provide some handy insights into the pipeline environment.
System variables, those are predefined by Azure DevOps. They give you a ton of info about the build environment, the agent running the pipeline itself. You have things like agent.name, which tells you the name of the agent running the job, or build reason, which tells you why the build was triggered. Lots of good stuff in there.
So I could actually use system variables to customize the behavior of my pipeline based on which agent's running it or why the build was kicked off.
Exactly. It's like having a built-in intelligence system for your pipeline.
Okay, that's pretty cool. Now let's address the elephant in the room. Those secret variables. Those are the ones we need to be extra careful with, right?
Absolutely. Secret variables are crucial for storing sensitive information like, passwords, API keys, certificates. Azure DevOps encrypts them and keeps them safe, allowing you to access them within your pipelines without, exposing them in plain text.
So if I need to use an API key to connect to an external service, I can store it as a secret variable and reference it in my pipeline without anyone actually seeing the key itself.
Exactly. Azure DevOps offers a few ways to manage secret variables. You can define them right in the UI, use variable groups linked to Azure Key Vault, or even inject them from outside sources.
Wow, lots of options. Sounds like Azure DevOps takes security seriously when it comes to sensitive information.
Security is paramount. Azure DevOps has a multi-layered approach to protecting your secrets. Okay, we've talked about the different types of variables. How do we actually use them in our YAML pipelines?
Right. It can't be as simple as just typing the variable name wherever you need it.
Yeah.
Right? There's got to be some special syntax or something.
You're right. There's a specific syntax for referencing variables in your YAML pipelines. The most common way is to use macro syntax, which looks like this: variable name. This gets replaced with the actual value of the variable before the task runs.
So if I have a task that needs to use a variable called build configuration, I would just put build configuration in the task's inputs.
Exactly. Azure DevOps takes care of swapping in the actual value before anything executes.
Okay, pretty straightforward. Now, what about when you need to use variables in conditions or expressions? Is the syntax different there?
You're thinking ahead. In those cases, you use runtime expression syntax, which looks like this: variables.variableName. It's evaluated when the pipeline is running, so it's perfect for dynamically calculating values or making decisions based on variable values.
So if I have a condition that checks if a variable called isProduction is set to true, I would use variables isProduction within that condition.
You got it. It gives you a lot of power to create dynamic and adaptable pipelines.
Okay, we've covered a lot on variables. Before we move on, I want to touch on something you mentioned earlier. Variable groups. They sound like a great way to manage variables across multiple pipelines.
They are. Variable groups are like shared containers for your variables. You define a set of variables once and reuse them in as many pipelines as you need. Makes things consistent and simplifies variable management.
It's like having a central library for your variables, and each pipeline can just check out the ones it needs.
Great analogy. And variable groups have a ton of benefits. No more redundancy, it's easier to update values across multiple pipelines, and they can even be linked to Azure Key Vault for extra security when you're working with secrets.
Okay, I'm sold on variable groups. But how do you actually create and manage them? Is it all done through the Azure DevOps UI?
You can manage them through the UI, but you can also manage them programmatically using the Azure DevOps CLI. That's great for automation and integrating with your existing workflows, especially if you're dealing with a lot of pipelines.
So if I'm comfortable with the command line, I can create, update, delete variable groups right from my terminal.
You got it. The CLI has commands for listing groups, seeing what's inside them, even exporting them to JSON files. Gives you a lot of flexibility.
That's awesome. So how do you link a variable group to a specific pipeline? Do you just reference the group's name in the YAML file?
You're close. You use the variables keyword in your YAML file. Just specify the name of the variable group you want to use, and Azure DevOps will take care of making those variables available to your pipeline.
So if I have a variable group called my shared variables, I can link it to my pipeline like this: variables.group, my shared variables.
Exactly. Super simple and concise.
Now let's talk about those variable groups linked to Azure Key Vault. You mentioned earlier that this is a more secure way to handle secrets. Can you break that down for me?
Azure Key Vault is a cloud service designed specifically for storing and managing secrets like passwords, API keys, and certificates. Linking your variable groups to Key Vault adds that extra layer of security and makes secret management a breeze.
So instead of keeping my secrets right in Azure DevOps, I can store them in Azure Key Vault and use variable groups to pull them into my pipelines.
Exactly. It's like having a separate, super secure vault for all your sensitive info.
Okay, I like it. How do you actually set up a variable group that's linked to Azure Key Vault? Is it complicated?
Not at all. You first need to create a service connection to your Azure Key Vault in Azure DevOps. That creates a secure link between your Azure DevOps project and your Key Vault.
Right, service connections. Those are what let Azure DevOps talk to external services securely, right?
That's right. And once you have that service connection to your Key Vault, you create a new variable group and choose the option to link secrets from an Azure Key Vault as variables. Then you just pick the service connection you created.
Okay, so I link the variable group to Key Vault using a service connection. Then what? How do I actually get those secrets from Key Vault into my pipeline?
Once the variable group is linked to Azure Key Vault, you just add variables to the group and select the secrets you want from your Key Vault. Azure DevOps will pull them in when the pipeline runs, just like with regular variables.
Wow, that's slick. Like having a secure pipeline to my secret vault.
You got it. Much more secure than storing them directly in Azure DevOps.
Now, I love automation. Is there a way to manage these Key Vault linked variable groups using the Azure DevOps CLI?
Absolutely. The CLI has a full set of commands for managing variable groups, including those linked to Key Vault. You can create, list, update, delete groups, and even manage the secrets inside them all from the command line.
So if I need to update a secret that's in Key Vault, I could just do it through the CLI without having to go into the Azure DevOps UI.
Exactly. It's a great way to automate secret management and integrate it with your existing workflow.
This is awesome. Azure DevOps really offers a lot of flexibility in how we handle variables and keep sensitive information safe.
Yep. Security and flexibility are key principles of YAML pipelines. With that in mind, let's switch gears and talk about another critical piece: tasks.
Tasks. They're the workhorses of our pipelines, the ones that actually get things done right.
That's right. Tasks are those individual units of work that your pipeline executes. They can be super simple commands like copying files or running scripts, or they can be complex operations like deploying to Azure services or running automated texts.
So, like, if I need to build my code, run tests, then deploy to Azure, I would define a series of tasks to handle each step.
Exactly. And one of the best things about YAML pipelines is that Azure DevOps has a huge library of pre-built tasks. They cover a wide range of common scenarios, so you don't have to reinvent the wheel all the time.
It's like having a toolbox full of tools ready to go.
Exactly. And if you ever need to do something that's not covered by those built-in tasks, you can create your own custom tasks or use task groups to combine existing tasks into reusable units.
We've already talked about custom tasks and task groups. Can you give me some examples of the kinds of tasks I might use in a typical YAML pipeline?
Sure. Some of the most common tasks include build tasks, which handle compiling your code, running any build scripts, and producing those build artifacts. Test tasks for executing your unit tests, integration tests, any other automated tests. And those package tasks, which bundle your application and its dependencies into deployable packages. Things like ZIP files, NuGet packages, Docker images. And of course, deploy tasks, which handle actually deploying your application to different environments. You could be talking about Azure services, on-premises servers, even cloud platforms like AWS or GCP.
Wow, there's a task for everything.
Azure DevOps is designed to be comprehensive, covering all kinds of CI/CD situations. But don't worry, you don't need to memorize every single task. The Azure DevOps documentation has a detailed task reference. You can search by category, platform, or even keyword.
So if I'm looking for a task to deploy my app to Azure Kubernetes Service, I can just search for Azure Kubernetes Service and it'll show me all the relevant tasks.
Exactly. And the task reference gives you all the info you need about each task. Its inputs, outputs, and any prerequisites. Super helpful.
Very helpful.
Yeah.
Now, how do you actually define those tasks in your YAML pipeline? Do you just list them out in the order you want them to run?
You're on the right track. You define tasks within jobs, and jobs are defined within stages. So the basic structure of a YAML pipeline looks something like this. You'd have your stages, and in this case, we'll have a build stage and a test stage.
Yeah.
Within the build stage, you define your jobs. For this example, let's just have one job called build job. Inside that job, you define the steps, and here's where those tasks come in. You'd use the task keyword followed by the task name and version, something like task, some build task at 1 or task, another build task at 2, and for each task, you can specify inputs to customize its behavior.
Got it. So stages contain jobs, jobs contain tasks, and tasks are defined using the task keyword along with the name and version, and then you can add inputs for each task to, tweak things.
Exactly. And within each task, you can also define multiple steps. Those are basically the individual commands that make up the task. But a lot of times the built-in tasks handle all that complexity for you, so you don't need to mess with individual steps very often.
That's good to know. YAML pipelines seem to have a good balance between being powerful and easy to use. Now, before we move on, one last question about tasks. You talked about using the iSecret flag with the task.setVariable logging command to protect sensitive information. Can you explain that a little more?
Sure. The task.setVariable logging command lets you set variables within scripts that are running as part of a task. But if you're setting a variable that contains sensitive data like a password or API key, you always want to use that iSecret flag.
So the iSecret flag tells Azure DevOps to handle that variable carefully and mask its value in logs and outputs, even if my script accidentally tries to print it.
Exactly. It's an important safeguard to prevent sensitive information from accidentally leaking out.
Definitely a good safety net to have. Okay, I think we've covered tasks pretty well. What other areas of YAML pipelines should we explore?
We've talked a lot about building and deploying apps, but we haven't really dug into the testing phase of the pipeline. Let's focus on that next.
Okay, testing, that's obviously a critical part of any CI/CD pipeline. What are the key things we should know about testing in YAML pipelines?
YAML pipelines give you a really robust framework for incorporating automated testing into your CI/CD workflows. You can run unit tests, integration tests, UI tests, pretty much any kind of automated test you can think of.
So it's not just about building and deploying. It's about making sure that what we're building and deploying actually works the way it's supposed to.
Exactly. Testing is essential for catching bugs early, preventing regressions, and making sure your software is high quality and reliable.
Now, are there any specific tasks or features that are especially helpful for testing in YAML pipelines?
There are a ton of built-in tasks for running various kinds of tests. For example, there are tasks for unit, unit x unit, and many more. You also have tasks for UI tests using frameworks like Selenium or Cypress.
So if I'm using a popular testing framework, there's probably already a built-in task for it.
Most likely, yes. And if not, you can always create a custom task or grab a community-contributed task from the Azure DevOps Marketplace.
Great. How do you integrate those testing tasks into our YAML pipelines?
Usually you define your testing tasks in a separate test stage. That stage comes after the build stage, where your code is compiled and packaged, and before the deploy stage.
Makes sense. Build, test, deploy, logical flow.
Exactly. And within that test stage, you can define multiple jobs. Each job can focus on a specific type of test or test suite. You might have one job for your unit tests, another for integration tests, and so on.
So it's a way to organize your testing and make sure everything runs in the right order and with the right dependencies.
You got it. And you can use the depends on keyword to define dependencies between those testing jobs, just like we discussed for regular jobs.
Right, right. Okay, once the tests run, how do we get feedback on the results?
Azure DevOps has a really good test reporting interface. It gives you detailed insights into how your tests performed. You can see what passed, what failed, and you can even dig into the specifics of individual test failures.
So if a test fails, I can see exactly where it went wrong and what part of the code caused the issue.
Exactly. Azure DevOps even integrates with popular test reporting tools like JUnit or NUnit so you can view results in a familiar format.
That's incredibly helpful. Sounds like Azure DevOps makes it easy to keep track of your testing.
It definitely does. And there's another great feature that can help streamline your testing. Matrix builds. Remember we talked about those earlier in the context of testing across different configurations.
Right, matrix builds. Those are the ones that let you run the same tests in parallel across multiple combinations of variables, different operating systems, browsers, that kind of thing.
Exactly. Matrix builds are super useful for testing because they let you test your code quickly and efficiently across a bunch of different environments and configurations.
So if I'm building a web app, I can use matrix builds to run my UI tests in, like Chrome, Firefox, Edge, on Windows and Mac OS, all at the same time. Make sure my app works for everyone.
Precisely. And matrix builds can save you so much time compared to manually creating and running separate test jobs for each configuration.
Definitely a time saver.
Yep.
Okay, before we wrap up testing, I want to touch on one more thing. Code coverage.
Code coverage, it's a metric that tells you how much of your code is actually being executed by your tests. It's a really good indicator of how thorough your testing efforts are.
So if my code coverage is high, it means my tests are hitting a lot of my code base. More chance of finding those pesky bugs.
You got it. Azure DevOps integrates with popular code coverage tools like Jacoco or Coverlet to track code coverage.
So I can see exactly which parts of my code are covered by tests and which parts aren't. Helps me focus my testing efforts where they're needed most.
Exactly. Code coverage is a powerful tool for boosting the quality and reliability of your software.
This deep dive into YAML pipelines has been super informative. We've covered so much, from the basic building blocks to these advanced concepts like templates, variables, and testing.
And we've really only scratched the surface. YAML pipelines are incredibly powerful and flexible. You can build really sophisticated CI/CD workflows that perfectly match your projects.
I'm excited to put all this knowledge to work. But before we wrap up, is there anything else we should touch on?
Let's talk about making sure our pipelines are as efficient as possible and run smoothly. Optimizing your YAML pipelines can make a huge difference in your workflow.
Welcome back to the deep dive. We've covered a ton of ground, from the fundamentals of YAML pipelines to more advanced stuff like testing and variable management. Now let's shift gears and talk about optimizing your pipelines for maximum efficiency and speed. Optimization. Sounds like something every developer dreams of. But where do we even begin? Is it all about just picking the fastest build agents and writing super efficient scripts?
Those are definitely important factors. But optimizing your YAML pipelines is kind of a multifaceted thing. It's about looking at your pipelines holistically and finding those areas where you can boost performance, reduce any waste, streamline your processes.
Okay, so it's a big picture approach.
Gotcha.
Can you give me some concrete examples of how we can optimize our YAML pipelines?
One of the simplest and most effective ways is to parallelize your jobs whenever you can. If you have multiple jobs that don't depend on each other, you can run them concurrently instead of one after another. It can really cut down on that overall pipeline execution time.
Makes sense, like having multiple chefs in the kitchen instead of just one. But how do we actually make that parallelization happen in YAML pipelines?
Azure DevOps has a feature called Parallel Jobs that lets you run multiple jobs at the same time. You can set how many parallel jobs you want to run, and Azure DevOps will automatically distribute them across your available agents.
So if I have a pipeline with 4 jobs that can all run independently, I can set it up to run those 4 jobs in parallel and potentially cut down my execution time by up to 75%.
Exactly. And you can scale that number of parallel jobs up or down based on your needs and what your build infrastructure can handle.
That's incredible. Now, what about caching? I've heard that crashing dependencies can really speed up builds, but I'm not entirely sure how that works with YAML pipelines.
Caching is a great way to optimize those build times. It's all about storing and reusing files or artifacts that are used often in your builds. Instead of downloading or building them every single time, you can cache them and grab them from the cache whenever you need them. Saves a ton of time.
So if I have a pipeline that downloads a huge library from a package repository every time it runs, I can cache that library and only download it again if it's been updated.
You got it. YAML pipelines have built-in support for caching, so it's easy to set up and manage.
Okay, caching sounds like a must-have for faster builds. Are there any other optimization techniques we should keep in mind?
Another key optimization is making sure you're using the right build agents for each job. Remember, Azure DevOps offers a whole variety of build agents, each with different capabilities and resources.
Right, we talked about that before when we were discussing how to use demands and capabilities to match jobs with the right agents.
Exactly. Choosing the right agent can make a big difference in build times. For example, if you're building a really large project that needs a lot of memory and processing power, using a more powerful agent with more resources will definitely speed things up.
So it's not just about picking any agent. It's about choosing the best agent for the task at hand.
Precisely. And Azure DevOps makes it super easy to manage your agents and pick the right ones for your pipelines. You can use self-hosted agents, which give you total control over the environment and resources, or you can use Microsoft-hosted agents, which are managed by Microsoft and come with various pre-configured environments.
And if we're using self-hosted agents, we need to make sure they're properly maintained and kept up to date, right?
Absolutely. Keeping your build agents updated with the latest security patches and software updates is just as important as updating any other software. It helps keep your pipelines running smoothly and securely.
Makes sense. Now let's talk about an optimization area that people sometimes forget about. Writing efficient YAML code. I'm sure we can all improve our YAML skills to help our pipelines run better.
You're right about that. Writing clean, concise, and well-structured YAML is essential for building maintainable and efficient pipelines. Avoid making things too complex, use variable names that make sense, and take advantage of templates and task groups to cut down on code duplication.
So basically, we should apply good coding practices to our YAML files, just like we do with our application code.
Exactly. Taking the time to write clean and efficient YAML will save you headaches down the road. Your pipelines will be easier to understand, maintain, and troubleshoot.
Great advice. Now, before we wrap up this deep dive into YAML pipelines, I want to touch on one last important topic: troubleshooting. Even with all these optimization tricks up our sleeves, things can still go wrong, and we need to be ready to tackle those problems.
Troubleshooting is part of life when you're working with software, and YAML pipelines are no different. The key to effective troubleshooting is knowing how to collect information and read those logs.
Right. The Azure DevOps UI provides a ton of info about each pipeline run. Logs, test results, error messages, the whole works.
You got it. And being able to read and understand those logs is essential for figuring out what went wrong. Pay attention to the error messages, timestamps, and the order of events to figure out what happened and why.
It's like being a detective trying to solve the mystery of a broken pipeline.
Exactly. And once you find that root cause, you can start working on a solution, whether it's fixing a bug in your code, updating a dependency, or tweaking your pipeline configuration.
This deep dive has been incredibly valuable. We've explored so much from YAML pipeline basics to advanced optimization and troubleshooting. I feel much more prepared to create, manage, and optimize my own YAML pipelines now.
That's awesome. And remember, this is just the beginning. The world of YAML pipelines is always changing, with new features and capabilities popping up all the time. Embrace the challenge, stay curious, and never stop learning.
Thanks for joining us on this epic YAML pipeline adventure. Until next time, happy building.